All right, let's take a look at the announcements for today. Homework 2, I just put on WebAssign. That's going to be due next Friday, but I kind of just make up these deadlines. So if we don't get to everything by Friday, then of course it won't be due on Friday. But for now, it's due next week Friday. Quiz 3 on Friday. Topics will be on rational functions or rational equations and inequalities. We'll kind of do some review at the end of class today. And of course, there's the extra credit opportunity for test 1. Do 5 worksheets, turn them in before the first test, and I'll give you 5% extra credit on that first exam. All right. Any questions on the announcements? All right. So I'm going to do the same thing as last class. I'm going to stop this screen share and somehow start the screen share here. Start. So before I go on, is there anyone who needs the copy of the guided notes? Anyone else? All right. Okay, so last class, we talked about some weird types of, here we go. Is that what happened last time? I guess that's what happened. Is there like a full? I do feel like it was bigger last time. What in the world?
Is there like a full screen option?
Maybe. Maybe it's like a full, oh, there we go. Awesome. Thanks, Shanor. Okay, so I think that's the size it was last time. I don't know. Okay, so we talked about different types of things. We talked about equations with like weird absolute value symbols. We talked about rational equations. Now we're going to talk about a different algebraic concept, okay? Very similar to equations, and I'm just going to write in the corner here, equations. Okay, the definition of an equation was literally anything that had an equal sign, right? So whenever you see a big algebraic thing with an equal sign in it, that's an equation, okay? Next, we're going to talk about inequalities, okay? Which is literally like what it says. It's not an equation, right? So we'll either have less than signs, greater than signs, less than or equal to signs, greater than or equal to signs. And we don't have any equal signs anymore, okay? So things are not equal with inequalities. Okay, so what I'm going to do here is we're going to go through a few examples of inequalities. I'm going to show you how to draw a picture of these, okay? And I'm also going to show you a different type of way to write your answer, okay? So let's just look at the first one. It says x is less than or equal to 2, okay? 2 other ways we can say this, okay? One is through like a picture, basically. And these pictures are kind of like an alternate way of like showing an inequality. You can go back and forth between the way you write inequalities classically, the picture, and the third way, okay? And since it's less than 2, I'm just gonna draw a circle above 2, just a circle. Okay, but I'm gonna actually do something weird to this circle. I'm gonna color it in, okay? And the reason I'm coloring it in is because we have an equal to in that less than or equal to sign. So because it has equal to in that sign, I'm gonna circle or fill in the circle. So x is less than or equal to, where should I extend my pink line? To the left or to the right? To the left, right? If you're not sure, what you can do is be like, okay, well, if x was, I don't know, -3, is -3 less than or equal to 2? Yes, right? But if I check any of the points on the right, like x equals 5, well, 5 is not less than or equal to 2, right? So it's definitely to the left. Okay, so if you ever get confused, you can always just plug in some points and see which way the line goes, okay? So I'm gonna erase this so it looks a little bit nicer, okay? Okay, so we have an inequality. We have a way to draw a picture of the inequality. We also have another way of writing this, okay? So I'm gonna take the boundaries of my line that I just drew, okay? The right boundary is pretty easy, it's 2, right? What's like the left boundary of this pink line? Infinity, negative infinity, right? Good answers. We have negative infinity. That line extends all the way up to negative infinity. It doesn't ever stop, right? Okay, so here's where things get a little confusing, okay? We have to put this in what I call interval notation, okay? I'll write that down. Okay, I wrote alternate notation. A lot of people write it as interval notation. And we're kind of gonna write this as a mathematical concept called an interval, okay? And what this means is, okay, I'm gonna write this on the side. We're gonna use parentheses that look like these, right? The curvy lines that you can kind of put around sentences. And we're also gonna use things called brackets, okay? Brackets are kind of like parentheses, but they're square, okay? So they kind of look like they have little edges to them, okay? And we use parentheses when we have these signs, greater than or less than, okay? So we use these signs. And also parentheses are used like when, I guess, a number is not included, okay? Okay, so how you know we use parentheses versus brackets? Parentheses are when we have greater than, less than, but not the equal to signs, okay? Or you can think of it as the number isn't included in the answer, okay? On the other hand, brackets, oh, did you have a question?
Like an example of like what you mean by that, a number that's not included?
Yeah, so let's take a look at this example. Actually, let's do the brackets first, and then it might make more sense when I do the other 2 examples of them, if that works with you. Okay, brackets are used when we have less than or equal to, or greater than or equal to, okay? Another way to say this is the number is included, okay? And if that doesn't make sense, it might make more sense when we take a look at this example here, okay? So, let's see. Let's do the 2 first. So we have x is less than or equal to 2. So over here with the 2, am I going to use a parentheses or a bracket? Bracket, good. Okay, what I mean by the number is included or not included, I mean we're putting a bracket because 2 is included. Does that make sense? I kind of said that a little weird, but yeah, 2 is included there. I wrote that really messy. Okay. Now, tricky one. Is negative infinity included or not included? Not included, right? We never actually reach negative infinity. Like, there's no way you can like get to negative infinity. So we always use parentheses for negative infinity or positive infinity. Okay, so because this is infinity, we use a parentheses. Okay. Any questions on this example here? Okay, let's look at the second example. Okay, x is bigger than 3. Okay, I guess I can plot 3, right? Put a circle. Should I fill in that circle? No, right? Because greater than isn't greater than or equal to, so I'm not going to fill in the circle. This is greater than, but not equal to, okay? And is my line going to extend to the right or to the left? To the right, right? Okay. There we go. Okay. So if I'm writing my interval notation, I definitely have a 3, okay? And the right-hand boundary is definitely infinity, right? It's the furthest out we can go, okay? Now, does the 3 get a parentheses or a bracket here? parentheses, right? Because we're not including 3, it's a less than or greater than symbol without the equals to, okay? And since we have infinity, parentheses, right? No brackets for infinity. Okay. Any questions on the first 2 examples here?
So how is infinity included?
Oh, so we used a parentheses here, which means it's not included. So infinity isn't included.
Oh.
Yeah.
The how is it? Okay, no.
Yeah, because like we can never reach infinity. So like there's no way you can like go further enough out to like get to infinity, right?
Infinity not included either because it's not like equal to.
Yeah. So this one is a parentheses because it's like greater than but not equal to, right? If that makes sense. Okay. Any other questions on the first 2? Okay. Okay, so let's go down to the third example. Well, now we have 2 numbers and x is kind of like smushed in between the 2 numbers, okay? So instead of like x is bigger than something, it's like -2 is less than or equal to x, but x is less than or equal to 1, okay? Here's how we graph this. Well, we have a -2 and we have a 1. So that's pretty easy to like plot, right? Which circle am I going to fill in? -2, right? Because this one has the equal to sign. The other one doesn't, right? Okay. And let's see. Well, over to the left-hand side, let me get my my pointer. Over here, if x was equal to -3, -4, or -5, well, that wouldn't be greater than -2, right? Out here, if x was like 4 or 5, well, x wouldn't be less than 1. So the only values that x can take on are in between, right? So x is in between -2 and 1 here. Okay. Any questions on how I drew the third one here? Okay. Let's go and talk about how we would write this in interval notation. Okay. Let's see. We have a -2 and a 1. Sorry. I wrote the -2 first because it's the less number, right? It's the less, more or less, lesser. It's lesser than 1. Okay. Okay. Which one should get the bracket? Good, because it's a less than or equal to sign, and the other one gets a parentheses because it's less than and not equal to. Okay. Any questions on how to write our inequalities, how to like kind of write the interval notation, draw a picture, anything like that? All right. Let's do something a little bit more difficult, okay? We are going to talk about how to solve the inequalities, okay? Now, inequalities and equations are very much alike, okay? So don't get too scared that there's an inequality sign and not an equal sign. Everything kind of works about the same, but there's one difference, okay? Anyone know the difference? The sign, right? So addition, subtraction works totally the same as inequalities versus equations, totally the same. When we get to multiplication and division, things get a little bit tricky, okay? I actually made a little mistake here, okay? When we multiply or divide, okay, you might have to add that to your notes. When we multiply or divide both sides of an inequality by a negative number, you have to flip the sign of the inequality, okay? So that's one rule that makes equations different than inequalities. And I think we'll see exactly how this works in our next example, okay? So I kind of want to switch my colors up. Let's do this green color, okay? So example 8, we have -3x plus 4 is less than 11. What should my first step be? Good, minus the 4. Okay, so let's see, we get -3x on one side, less than, and 11 minus 4 is 7, right? Okay, so just like a regular equation. Okay, what's my next step? Good, divide by -3. So on one side I get x, right? The other side I get -7/3. But what's my sign now? Greater than, right? Because whenever you divide or multiply by a negative, you flip the sign. Okay, so I kind of just flip the sign over. Now x is bigger than 7/3. Okay. Any questions how I got to the answer here? Okay, why don't we do this? We're going to represent our answer as a graph, okay, and as an interval. Okay, so let me just take this graph here. Okay, okay, here we go. We have -7/3. I just typed that in my calculator. I think it's like -2.3. So I'm going to draw a circle above wherever that might be. Okay, and x is to the right, so I'm going to extend my line over to the right. Right, x is bigger than -7/3. Okay, we can also write our answer in interval notation, right? We have -7/3. And the rightmost boundary is infinity, right? Okay, so on the left-hand side, do we have a parentheses or a bracket? Parentheses. And what about with the infinity? Parentheses, right? Infinity always gets the parentheses. Okay, so we solved our equation. We represented our answer in 3 different ways. And yeah, okay. How about this? Try example 9. I kind of try to trick you here. There's really, or there may or may not be a flipped sign here, okay? But try this one on your own. I'll be around to kind of check out your answers and we'll come back in a bit. All right, how about this? Let's come back together. Amelia wrote a really good answer on the board. So do you want to take us through your steps here?
Yeah, so I subtracted the 2x.
Mhm.
And then I got 2x minus 3 is less than 5. And then I added 3 to both sides.
Mhm.
And then I got 2x is less than 8. And I divided by 2. And got x is less than 4.
Mhm.
And then to graph it, I used the open circle because the 4 is not included. And
Mhm.
then I do the arrow to the left because it's less than x. There's everything less than it. And then for the notation, it's going from negative infinity and it's not included. Infinity to 4, which is not included. So it's also.
Awesome. Awesome job. Any questions on example 9? All right, let's make things take it up a notch a little bit more. Okay, so if you flip the page of your notes, we have example 10. Okay, and this kind of goes through an inequality that is a little bit more complicated, right? This is kind of like our 3rd example up in that chart. We have x, but it's kind of smushed between 2 numbers, right? Okay, now I've seen this done multiple ways. Okay, I know people can get really confident and kind of keep it like it is and not split it up and solve it and get totally right answers. Totally fine, up to you if you want to do that. But I kind of get confused when I do that. So what I'm going to do is kind of show you my way of doing this, where I don't get confused, because I feel like I make a lot of simple mistakes. Okay, when you see something that's smushed between 2 inequalities, I like to split up the inequality into 2 different ones. Okay, so I'm going to have a left-hand side and a right-hand side. Okay, so for the left-hand side, what I'm going to do is just write the same inequality. Okay, but I'm going to kind of take out that less than 12. So I'm ignoring the whole right-hand side. So So I literally just took the left-hand part of the inequality and ignored the less than 12. Okay. The right-hand side is the same thing, but I'm ignoring the -10 is less than or equal to part. Okay. So -2x minus 6 is less than 12. Okay. So I kind of just split this up into two different equations or two different inequalities. One is the left-hand side, the other is the right-hand side. Okay. Let's simplify the left-hand side. Okay. Okay. What's my first step in solving this equation here, inequality? Good, add 6 on both sides. So on the left, we get -4. On the right, we get -2x. Okay. What do I do to finish up this inequality? Yes, divide by -2 on both sides. So on the left, I get 2, and on the right, I get x. What is my sign going to be? Yeah, greater than or equal to, because I divided by a negative number. Okay. Now, I got a couple of questions on this in my last class, and I think it's kind of important to go through exactly the steps to change your answer if you want to, okay? This is a totally fine answer. Would take this answer 100%, okay? You can actually graph this answer pretty easily, okay? Why don't we just go down here and try to graph it real quick? If x is, if 2 is bigger than or equal to x, okay? Well, I would draw a circle at 2, maybe fill it in, right? Because it's greater than or equal to. What side is going to get the line here? The left, right? Because over here, if we just kind of, I don't know, pick a x, right? X equals -4. 2 is bigger than or equal to -4, right? So that works. I kind of like Katie's idea. Do you kind of want to take us through the arrow? So yeah. I guess what you're saying is there's an arrow. You can kind of view this as an arrow, right? So this is like an arrow pointing this way, which I guess doesn't really help. Can you kind of?
Because the 2, so the number that you have is at like the end of the arrow.
Oh, so it's like
if you have the x first, then it would be like the opposite. But since you have the 2 at first, it's gonna it's gonna trick you if you don't really pay attention. It's gonna trick you on that.
Oh, okay. I see. I see
So
what
you just gotta focus on what comes first, the x or 2.
Okay. Yeah. So I guess you're thinking about, okay, maybe we should get x to the left, right? Okay. I feel like I got a few questions on this in my last class. Kind of, I feel like everyone kind of knows if we want the x on the left, we can kind of like flop over the whole equation, okay? So maybe we can rewrite this as x is less than or equal to 2, right? Just kind of flipping over the equation, okay? If that's not connecting, because I feel like it's a big hurdle to go from there over there, we can even rearrange the equation by doing this. Well, okay, I want x on the other side, so I can subtract x on both sides, right? So this becomes 2 minus x is greater than or equal to 0, right? I want 2 on the other side, so let me just subtract 2 on both sides. So I get -x is less than or greater than or equal to 2, but I have a negative attached to my x, so I need to divide by -1, and that gets me over there where I need to flip the sign, okay? So if you can get from here to here in your head, that's fine. You might need to take these steps if that's not connecting, okay? Okay, so 2 ways to write our answer. 2 is bigger than or equal to x, or x is less than or equal to 2. Both works. Whichever one you feel more comfortable graphing is what I recommend you to do. Okay. Any questions on how we got either answer for the left-hand side? Okay. Let's do the right-hand side real quick. Same steps, right? We add 6 to both sides. So we get negative 2x is less than 18, okay? Then we divide by negative 2. So we get x and negative 9, right? Is that right? Yep. But we have to flip the sign, right? So this becomes, oh no. Oh, oh my God. There we go. Is greater than now because we divided by a negative number. Okay. Okay. And I guess x is on the left here, so we don't really need to rearrange anything, right? Okay. So let's graph this part of the equation. So we have negative 9, right? Let me kind of just extend this line over. We have negative 9. We're not filling in the circle, and x is bigger than. So does my line go to the left or to the right here? The right, right? Okay. Huh. Well, we have two conflicting pieces of information here, right? We have a circle at negative 9 that goes out, and then we have a circle at 2 that goes to the left, right? Well, our final answer has to be like the overlap between the two, okay? So what's true for both of these, okay? Well, let me do this. I'm going to kind of lasso this, okay? And move this down, okay? Okay, well, let's see what they have in common. Well, we still have our circle at 9, negative 9, and our filled in circle at 2, okay? But they overlap everywhere in between, right? Okay, anything else isn't included in both the top and the bottom line, okay? So the overlap between the two is everything bigger than negative 9, 2, and everything less than 2, okay? Does that make sense? So we're kind of combining our two answers from the left-hand side and the right-hand side and thinking about where they overlap. Okay, so we finished our graph. Okay, let's write our interval notation. Okay, so we have a negative 9, we have a 2. Does negative 9 get a parentheses or a bracket? Parentheses, good. And I guess the 2 gets a bracket because it's filled in, right? Okay. Any questions on example 10? All right. How about this? Flip the page over. We're going to do example 11 in pairs by yourself if you want to. I want you to get to the answer. I want you to graph your answer, and I want you to write your final answer in interval notation.
2 hours later.
Front of the class. I got Eldon to write his answer up. Do you kind of want to steps here? Yeah.
And I divide the 2 from both sides, it would be x is less than or equal to 3.
Yep.
Go down to the I filled in 3 and then 1.
No, you're good. Awesome. Awesome. Okay. Does anyone have any questions about this example here? All right. So what we're going to do is we're going to stop class here, but I do have a quiz review for you. We probably don't have enough time to go through too much of it, but I do promise to get the answers outside tonight. right? And we will work on it now. I also have office hours today and tomorrow.